So I want to talk to you a little bit about creating set-driven keys inside Cinema 4D. Now, before I do, I just want to kind of qualify this presentation by saying that this is not a requirement, but this may save you a lot of time in the long run. It takes a little bit of setup on the front end. Technically, it can appear to be a little complex to get over the hump of some of the concepts, but once you do, it's going to save you a lot of time in terms of animation. Now, my whole goal with this presentation, you could probably build this project based on everything that you already know. You can model something that's technically interesting. You could have it explode over time and create a really compelling presentation without even reviewing these presentations. And actually, you can do that. I don't have any objection to that as long as you present a fully realized project for the end of this class. Now, I'm going to show you some tips and tricks. You can pull what you want out of here, decide to use some of those. The key takeaway from the previous presentation is that you're setting up your beginning and your end keyframes before you even start animating. And that's a pretty typical strategy when it comes to animation. With this next presentation, I want to clean up the existing animation that I have and build some dependencies so that the only thing that I have to animate maybe is that first element, that cone object. Maybe I'll pull that off the rocket and I want to cause that other stuff to kind of trail behind it. The way I'm going to do this first is I'm going to jump into my timeline. I'm going to select the summary element here, and I'm going to hit the delete key. That removes any animation that's been assigned to my model. So the previous demonstration has completely been wiped out. I still have 180 frames. I'm going to rewind my playhead to the beginning of time, and I'm going to focus on the timeline here just a bit. Or excuse me, I'm going to focus on the object manager. Now, before I demonstrate this inside my active project, I'm going to create a new document and show you the concepts here using two different pieces of geometry. I'm going to use a sphere and a cube. I want to show you this concept of set-driven keys. So I have a cube and a sphere, and I'm just looking here. My sphere is on top visually in my space, and yet it's on the bottom in the object manager. This is just a little nitpicky thing, but I want to reverse those so that my sphere and my cube hierarchically correspond with what I see in my viewport. Now that's not technically required, but it's something that allows me to keep track of what I'm looking at in a pretty clear way. What I want to do is I want to create a dependency between the sphere and the cube that causes, when I move the cube, when I move the sphere, the cube moves with it. Okay, and we're going to use this concept of set-driven keys, or set driver, set driven. It's fairly simple to create a relationship in Cinema 4D that causes one object to move with another. And you might be saying, well, I could just group these two objects and then they move together. Well, we gain a lot of control when we start to establish set-driven keys. And the way that we create set-driven keys is that we select the object that we want to define as a driver. And I'll present this process really quickly, and I'll review it. I'm going to select the sphere. Now the concept here is that when I move this object along the y-axis, okay, so if I look at the coordinate system and I look at the y-axis, that's the thing that's moving. This number is increasing as I move this. I want that to influence the y value, the y position value of this cube here. So the way that I'm going to do this is I'll just move this kind of back down in space. I'm going to select the sphere. I'm going to go to the coordinate tab in the attributes manager, and I'm going to right click on the y position value. Okay, I'm going to right click on the y position value. I'm going to choose the animation drop down menu, and I'm going to choose to set it as a driver, set driver. Okay, now what I've done is I've just told Cinema 4D to track this as a driving element. Now what I want to do is I want to set a driven relationship, and the thing that I want to drive is the cube. So I'm going to select the cube. I'm going to go to the coordinate manager. I'm going to right click the y position value. I'm going to choose animation, and the sphere I set as a driver, the cube I want to set as a driven, and I have a choice to set it as a driven absolute or a driven relative. And if I set it at driven relative, in most cases you want to do, I would recommend relative until you have a compelling reason to use absolute. Right now, when I select the sphere and I move its y value up or down, the cube tracks the y value of the sphere and makes it equivalent. Okay, and you might be scratching your head saying, well, I could have done that with grouping the object. Well, if I select the cube, I can move the cube, or I try to move the cube, and the cube doesn't move along the vertical axis because it's set to be driven by the vertical value of the sphere. I can move it along z and along x, and then when I grab the sphere and I move it up, it tracks the vertical position. I'm going to undo and get that cube back to its original position. Now you might be saying, well, why am I looking at this? What's so compelling and interesting about that? It's basically like a grouped relationship. Well, you notice that when I set the driver on the sphere and I completed the process by setting a driven element of the cube, I got a little tag that popped up here, and this is called an Expresso tag. Expresso is a very powerful element inside Cinema 4D, and in fact, we take a deeper dive into this in the simulation class. But I want to kind of introduce you to the concept of this Expresso node. Now, this Expresso tag that pops up, if I double-click on it, we actually end up in the Expresso editor. Just going to double-click there. And I'm kind of getting a funny, this is pretty atypical here. Typically, when you double-click on that, you'll see this Expresso editor pop up, and these nodes are not stacked on top of itself. I don't know why it looked like that, but yours should look just like mine when you double-click on that. When I double-click on this Expresso tag, it opens up the Expresso editor, and it shows me these different nodes of this relationship that I've just created. And basically what it's saying is that the sphere y position is driving the cube y position, okay? Again, we take a deeper dive into this in the simulation class if you want to get into it. But what I want to do, so I'm just going to reposition this a little bit so we can see a little bit more clearly. There's this node right in the middle of these two elements called a range mapper, and when I select that range mapper, down in the attributes manager, there are some values that pop up. And there's an input lower and an input upper, and there's an output lower and an output upper, and basically what this is saying, and I'll just close this for a moment, what the input is saying is that when we input or we move that y value, it's going to influence the values of y for the cube. And so the input lower and input upper represents the position of the sphere. Okay, you might be scratching your head saying, whoa, this is, what are all these numbers? Basically what we do is when we move the sphere up, there's a one-to-one relationship between the input, the value of y, and the output, the value of y on the x. But if we changed this output upper value and made it less than its existing value, let's say, I'll say minus 10. We'll make it less by 10. So I just did a little bit of math in here. I could have done the math manually and said, instead of negative 100, or excuse me, instead of negative 80, make that negative 90. I'll select the sphere. Now when I move that up, it's not real dramatic here. Let me give myself a little bit of space. Now when I pull that up, you can see that the relationship of the sphere is actually that when I move this up, it's moving a little bit faster than the cube. Okay, so the farther I move this sphere up, the bigger that gap between the cube and the sphere. Okay? So that was a lot of information. Let me just wipe out all that stuff. Let me boil it down to the essentials. Here's the routine. I'm going to create just two objects just to demonstrate this point one more time. I got the cube. This time around, I'm going to move that up. Well, let me just be consistent here. Let me move the sphere to the top again. I'll select the sphere. I'll move that up. I want the y value of the sphere to drive the y value of the cube. I'm going to select the sphere. I'm going to go to the coordinates manager and right-click on the y value of the position. Choose animation, set driver. I want to go to the cube, go to the coordinates tab, right-click on the y position, go to animation, and set that driven to relative. So I have a driver, which is the sphere, and the driven, which is the cube, and they're both interacting with the y-axis. Now, if I double-click on this new little Expresso tag that popped up on the cube, double-click, I get the Expresso editor that pops up, and I see the three different nodes that go into the relationship. And again, it's the sphere is mapping, the sphere y position is mapping directly to the cube's y position. But there's this thing in the middle called a range mapper, and that allows us to change the relationship. Right now we have a 1-to-1 value of the position of y of the sphere to the position of the cube, and I just want to change that value just a little bit. And I can do that by selecting on the range mapper, going down to the attributes manager, and lowering the output upper to a value. Now, the value with which you want to lower it depends on how large of a scale that you're working at. So if I change this from 100 to, say, 80, when I move that sphere, that cube is going to move a little bit slower. And if I want to make it move slower yet, I'm going to select that range mapper, go to the attributes manager. The lower this value gets, the slower it's going to move. So let me make it 50. Okay, now this is on a scale of 100 points or 100 units. And so you'll notice that the input lower, there's 100 from the lower to the upper. And now the output lower to upper, there's a 50. So there's a 2-to-1 relationship between how far the sphere is going to move versus how far the cube is going to move. Okay? Now, we can take that concept, the set driver, set driven concept, and actually apply that to our exploded view model so that we only have to really animate one thing, one element, and have the explosion occur. And I'll do that in the next presentation.